Hi guys, welcome back to CVRROCKET, and today in this video we are going to see about CNN, forward propagation a little bit, and backward propagation, and we will see how we can able to extract the features out of the image. Majorly these are CNN are used in images, videos, and videos again collection of images. So for those processing we will use CNN mostly. So how features are extracted, like edges, all those features are extracted from the image. And how it is processed, and how we used to do prediction based on classes. If we have two classes, how we are going to predict. For prediction we need to train a model, so how the training happens, and later on how prediction happens, all those, like inference, how training, and afterwards how inference happens. Nothing but inference is nothing but prediction. So that we are going to see in this module. So yeah, first we are going to talk about convolution and correlation. There are actually two operations. Convolution is one operation, correlation is one operation. There is a relation between those that we will try to figure it out. For example, if we are given a 3x3 image like this, and as you know, each grid in the image is a pixel, and it can be denoted within the range of 0 to 255. It's actually the brightness. It's whether it's white or black that it indicates. So based on that combination, image is formed. And again, this is a single channel. If you have multiple like this, we will be having 3 channel actually, RGB. So based with that we will get colored image. So for example, this simple black and white image, or with combination of black and white, we will also able to form grayishness in the image. So just this is a simple one image. If you can take single channel, and we have a filter. Here it is a filter, means it is actually some sort of slides or weights actually initialized over here. With that we will be able to get the features out of the image from this. Using this from this image, using both this, we are trying to get some image, like features from this image. For example, if you have image something like this, some person is portrait image, we need to find these edges, all these edges. This all those are edges. This is like vertical edge, this is a horizontal edge, this is horizontal, vertical, this circular. All these features can be extracted using certain filters. So we need to design those filters like this. We need to initialize parameters like this, like that, and gradually when the model is training, it tries to figure out that using this filter it is able to find vertical edges, it is able to find horizontal edges, rounded edges, circular edges, boundary edges, all those. That we will see in detail how those works. I'll just give you some examples. For now, assume this has a kernel or filter K, and this is input image, and here we are doing some operation. Actually what it is I will tell, but the operation procedure or algorithm is something like this. This total slide 2x2 grid on 3x3, this is just an example, travels from like this. Here it will start from here, what I am drawing, and it will perform 1 into 1. Where is 1? Yeah, 1 into 1, and then 4 into 5, 5 into 4 for suppose, 3 into 0, and then 2 into -1. Sum of those products we will get 19. So that will be over here. Then it will slide. If we have stride length 1, if we have stride 1, that means it will just move one step ahead. If we have 2 means it will move 2 steps ahead. So here it is 1 for example. Then second will be 5 into 1, 4 into 4, 2 into 0, 8 into -1. So it goes on like this. From here it will move down, stride length again 1 means, so down also 1, it will come over here, then it will come over here. So we will be having 2 into 2, and formula is something like this. This is y actually, this is y, I is this one. So 3x3, it's like again it will be square. So 3 minus k is 2, so 3 minus 2, 1 plus 1, 2, so 2x2 will form. So it's actually y by y. And but what statistics and what the theory suggests is like this is actually cross correlation, not convolution operation. Again, we only gave the names, but these mathematical operation what is different. This mathematical operation is different, like cross correlation and convolution operation. In terms of mathematical operation, what we do is different, and thus the naming also we gave something like this, like that only. So this operation what we are doing mathematically is actually not called convolution. So names are given by us only, but operations are also different, so we also need to give names differently. So actually it is cross correlation. What convolution actually does is we have to shift this kernel filter image by 180 degrees. That means we need to rotate like this 180 degrees. So minus 1 will come over here. You can think out like in 2 by 2, you can just think like this will come over here, like crisscross. 4 will come over here, 0 will come over there, minus 1 here, 1 will come over here. So that is only happening. Or you can just imagine rotate it by 180 degrees, right hand side clockwise. So minus 1 will come over here, 4 will come over here, and 0 will come over here, and adjacent to 0, 1. So 1 will come hop on over here, right? Or else minus 1 will come over here. So I think you got that. If you rotate this kernel by 180 degrees, then perform this operation cross correlation, which we are assuming, which we are set now, then what happens is that you will get different result than this what we have got over here. And you can again perform this. You have to map over here, map here, map here, map here, and again perform those some of the products which I have said. For example, here 1 into minus 1, 0 into 5, 3 into 4, and 2 into 1. So yeah, we will get this 13 as an answer. So what you're saying is convolution of ik is nothing but I cross correlation of rotation of 180 degrees. So if you will rotate the kernel by 180 degrees and then perform cross correlation, that is nothing but convolution, and we are denoting it by star circled, and cross correlation is star. This again rotations we are giving, they gave, that's it. So for our convenience we gave. So nothing like very important thing actually. So just a notation. So why this small change is there, we will see in the later part. Now we will move on. Further some notations are there. Now for example, this is an image and this is a kernel, and we are performing cross correlation, valid cross correlation. So there are two types, valid and the full. So we'll talk what all those about. So for example, valid, we have done previously a valid only. So this is the input image, kernel image. We have to slide like this. We have to map entirely over here at first step. And then we have to slide. For stride 1 means we have to slide like this, and we get the result. But for in the case of full, we need to start from top actually. So that means in the image we are just taking first cell and we are mapping this with this, and the result will be minus 1 into 1 because others are 0. So we will just get minus 1, and then it will slide from here. So now result will be 1 into 0, 0 plus 5 into minus 1. That is nothing but minus 5. And then we have to slide something like this. So it will be 5 into 0, 4 into minus 1, minus 4. So, and then we will slide over here, 4 into 0, it's nothing but 0. So that's how it will fill. Afterwards what happens is it will come down one stride. If we are taking stride for, so all this example are I'm taking stride length 1. Then we have to come down and it will go here, here, here. That means if I have to show over here, this is the first in second row, second, third, fourth. That will fill this column, row. This row will be filled with that. Then we have to move down 1, 2, 3, 4. This row will be filled. Then at last only one cells will be there. 1, 2, 3, 4. Again give the result for this. Only one cell means 9 into 4. That is nothing but 36. 9 into 0, 2 into minus 9 into 1 plus 2 into 4. So 9 plus 8. That is nothing but 17. Then here 2 into 1. Right, and then 5 into 4, 20, 22. At last here only 5 into 1, 5. So this row is filled, this row is filled, so all those rows will be filled. So again, as you can see, the length of the matrix, output matrix which we get is increased actually.